them talking and giving ideas, and that was really wonderful. And of course, in 1997, we met at the copy machine, as it was in the written that, and maybe you have to have some more copy machine around the hallway, and so the people can stand there and talk. But you know, Drew came from NIH, and I was already here in 1997, already 8 years, and working with doing messenger RNA things. And I brag about that I can do RNA, and Drew was interested in vaccines, and that's how our collaboration started. We never worked even in the same building. We were in different building, different department, but we collaborated and had fun.
I mean, we worked side by side all of that time because we couldn't get funding, we couldn't get publications, we couldn't get really people to notice RNA as something interesting. It had failed clinical trials, and pretty much everybody gave up on it. But you know, Katie lit the match, and we spent the rest of, I don't know, 20 plus years working together, figuring out how to get it to work, how to get a vaccine to function well. And COVID hit, and the vaccines were recognized for 95% efficacy, which was really a turning point in RNA therapeutics. We would sit together in 1997 and afterwards and talk about all of the things that we thought RNA could do, all of the vaccines and therapeutics and gene therapies, and just realizing how important it had the potential to be. And that's why we never gave up, and we just kept persevering and kept working at it, and here we are today. Thank you.
Thank you. So now we're going to transition to our Q&A, and as I mentioned, we have some questions that have been submitted from members of the media. So our first question comes from Kristen DeGroot at Penn Today. Where were you when you heard you won? Tell us about that experience this morning of getting those calls.
I mean, I get the first call, although they tried to reach Drew, but somehow their telephone number did not work. So they called me up. It was 3:40 or something, very early, and my husband picked up the phone and talked to somebody and said, you know, this is for you. So he handed over the telephone, and you know, was said that, you know, me and Drew Weissman, who received the Nobel Prize today, and I was like, I didn't know whether it is real, you know. We suspected maybe some, you know, prank, yeah. Maybe, I don't know. People report things like that, and anyway, so I also gave them Drew's number, that too, you know, cell phone number, which, you know, a week ago still was working. Yeah. although at that time you didn't answer either. Anyway. But anyway, so that's how it happened.
Yeah, I mean, so yeah, Katie texted me, and this got a cryptic message at 4 in the morning. Did Thomas call? And I'm there. So I texted her back and said, no, who's Thomas? And she says, Nobel Prize. And then I call her, and we talk, and she tells me about the message, and they couldn't reach me because they had the wrong number or whatever. And we said, you know, this has to be a prank. Some anti-vaxxer is you know, playing with us, and you know, this can't be real. But you know, we sit back and we wait for the announcement, and I FaceTime my older daughter, who works in the medical communications field, and she says, you know, okay, let's wait for the press conference. And we sat in bed and, you know, looking at my wife, and my cat is begging for food, and we wait, and the press conference starts, and it was real. So then we really became excited by this.
Thank you. So the next question comes from Alice Park at Time Magazine. Did you expect to win a Nobel for your work so soon after its first successful application in the COVID-19 vaccines?
I mean, we are not working for any kind of award. We were just having some product. I mean, last 9 years I worked at BioNTech, and the importance was, to have a product which is helpful. And so I was not thinking about getting.
Yeah, I mean, Thomas actually asked that question and said, did you think it would be this quick? And I said, well, I never expected my entire life to get the Nobel Prize, and it's an incredible honor. But no, I wasn't expecting it this quick. And he said, yeah, we kind of figured that was going to happen, but they said we wanted to be more current, and we wanted to recognize things more, usually it's 9 years, I think, is the average after a big finding before they honor people with the prize. And he said the Nobel Foundation wanted to be more current, and that's why, and you were probably surprised that it was only 3 years and not 9 after the finding.
And who is Thomas?
So Thomas Perelman is the Executive Vice President of the Nobel Prize Organization, and he's who called us with the announcement.
Our next question is from Lauren Young at Scientific American. How can this mRNA technology be applied to other therapies, such as cancer immunotherapies, and where would you like to go next?
Yeah, so this is something that my lab and Katie at BioNTech has been studying, and really the whole world. Everybody thinks RNA was invented in 10 months, but the first clinical trial was 1995, 96. It's been around for a long time. Clinical trials with modified RNA started in 2018, and they've been going on ever since. We had 3 clinical trials going on before COVID hit. So this isn't a new thing. And since COVID and all the attention, we've been able to tell the world about what we're doing. But we've got clinical trials for 7 vaccines going on right now. We've got work on cancer vaccines, vaccines for autoimmune diseases, for allergies. We've got gene therapy moving into clinical development. We've got a variety of therapeutics. So, it's already been going on for many years, and this has just given RNA the recognition.
Yeah, so because actually 10 years ago was the first mRNA therapy meeting, and those, if you would attend every year, you would know that how many things already were, in trial started, so CureVac is the first company. 2000 was established to develop a cancer vaccine, and BioNTech is an immuno-oncology company, not just for mRNA but other things. But mRNA also was 2012 was the first cancer vaccine trial. So, and as Drew mentioned, for example, Moderna has for heart failure, VEGF-A mRNA with AstraZeneca. They already started, and phase 2 trial was running, so everybody thought that maybe that will be the first approved product. So if this pandemic would not happen, still we would have mRNA product, but it accelerated. So the more money was poured in, and so that's why more product. So more than 250 clinical trial ongoing on mRNA right now.
Thank you. Our next question comes from Penn Medicine. So how did it feel to watch COVID vaccines roll out?
So it was actually funny, and my family would yell at me about this. After the phase 1 clinical trials, I was already working on other things and kind of ignoring the vaccine. We were working on pan-coronavirus vaccines and influenza and HIV and many other diseases. So I sort of paid attention to the vaccine development, but was really focusing on what was next, what would be the future of RNA therapeutics. And that my wife had to come and grab me and say, oh, they just released the phase 3 results, and they were 95% effective. And I said, oh, great, I was expecting 100%, but I would expect 95.
So I was working at BioNTech, and BioNTech and Pfizer already signed up an agreement in 2018, many people were not aware of, to develop messenger RNA-based vaccine for influenza. And that was already, so we worked together, so it was not when the pandemic happened that we met the Pfizer colleagues. And we were already ready to start human trial for influenza vaccine. So, but the mRNA therapy is so simple that you have to change the template, and then you can get a new product, because the RNA is always four nucleotides there, and so that's why it is wonderful, not that you can have multivalent, because you can have mRNA coding for many different proteins. You can put in the same vial and inject once, because otherwise with protein they can be sticky or charged, and they would get aggregation. But this is simple with mRNA. But answering your question, so BioNTech started to work with Pfizer early on.
Okay. This next question is for Dr. Carrico. So you are among only a few women to receive a Nobel Prize in medicine. What would you say or what advice would you have for other women making their way in science today?
Yes, so I usually, when I have audience and maybe students, I usually tell them to find the right husband, first of all, who is, supporting your dreams, that, not serving you, but, that realizing and helping you, and raise the child if you decide to have one. And I always mention that mental and physical health is very important, so that exercise and handle the stress, and you have to enjoy. If you don't enjoy what you are doing, then you shouldn't do. So that if I usually say, if you like the spotlight, then you should be an actor, an actress. And if you like to follow instruction, maybe military the best. If you want to be rich, I don't know answer for that, but if you like to solve problems, that, science is for you.
Thank you. So this will be our last question, and maybe we'll start with you, Dr. Weissman. Why should young people, so following on that, why should young people go into science today?
No, nowadays, there's really a dearth of young people wanting to go into science, wanting to go into academics, wanting to investigate. They want to do, IT and become rich and retire or whatever. But for me, science is a place, if you want to ask questions, if you want to say, can I understand things better? Can I investigate new things? Then science is the place for you. In order for our society to move forward, we need science. Everything that's moved our society forward in the past thousands of years has been science-based. The invention of the round wheel, the invention of transportation, the invention of antibiotics, of other medical therapies. All of that is science-based. So we need to encourage our children, our grandchildren, our neighbors, everybody, that science is what moves the world forward. And that's why it is so important. And it needs to be supported. And we need to get our children and everybody else to believe in it and to follow it.
So that we see in these days, and maybe it's wrong, but the young one, they want the instant gratification constantly. Somebody is tapping their shoulder and praising them, but in science, is something that you don't get this one. You have to learn how to handle the failure, because most of the time, we don't understand, we make experiment and the outcome is not what we want, and but you can learn that, and you can, with the success, they usually say that after failure, with the same enthusiasm, you move on. And if somebody likes to solve a puzzle, where some answer will be helping somebody to cure something, is just so wonderful thing to do. And we emphasize we worked hard, but we enjoyed.
Yeah.
So that's what we have to reflect. I mean, it's not coming easy, but it is fun, and we do it with great happiness.
Thank
So
you.
that's what I would say.
Well, on that wonderful note, I want to say thank you to Dr. Carrico and Dr. Weissman, and maybe we can give them one more round of applause. Joining us today, both here in Philadelphia and those of you who are joining us virtually from around the world. Just a reminder that you can find updated information about our Nobel laureates on our website, including a recording of today's press conference which will be available soon. So we hope you enjoy the rest of your day. Thank you for being here.